Hello friends, I am Rohit Kumar Rudrapa Wagdarikar, working as an assistant professor in Computer Science and Engineering Department at Walchand of Technology, Solapur. Today, we are going to take a session on system calls in operating system. Now, the learning outcomes of these sessions are, after the completion of this session, students will understand the concept of system calls, which includes what is system call, system services provided by the system call, types of system calls, fork system call, and examples on some system calls like a fork. Now, what is system call? The system call is a way for the program to interact with operating system. System call is a system program which instructs the operating system to perform the specific task. Actually, in operating system, all the tasks are done by the system calls only. Like if we want to perform some operations on files, then we need to perform or execute the system calls like open, create, delete, update, kind of things. So now we'll see the next thing. The services provided by the system calls. Now, in operating systems, each and everything is treated as a process. Now, the system calls are related with these are the process creation and management, in which we can create the multiple processes and we can perform some operations on the process also. And that will be handled by process creation and management. Main memory management. Now, when the actual programs come for the execution, at that time we can call it as a process. Now, that program is come for the execution in the main memory. So, allocation of memory to each process, all these things are done under this memory management. Now, in that way, processes are performing some operations on some directory and files. So, this kind of system calls are handled by the directory and file system management. Now, the next one is I/O device handling and network management system calls. Now, the types of system calls. Now, in the previous slide, we have seen like under process management. Now here the process control system calls. In this we'll have the end system call, abort system call, create, terminate, allocate, and free memory system calls. In that way, in a file management system, we can create a file, open a file, delete a file, read file. All these operations will be done under this file management system call. Now, device manipulation. In device manipulation, we'll perform the I/O control and we can perform the read and write on these devices also. Now, in information maintenance, here we'll get the details about the different processes, like we'll get the process PID, that is process identifier, and then we can also take some values like alarm and sleep also. So these are the different types of system calls. Now let's take one example called fork system call. Fork system call allows the system to create a child process which run concurrently with a process called the parent process. Now, child process uses same program counter which used by the parent process, same CPU register which is used by the parent process, same open files which used by the parent process. Now, when we'll execute this fork system call, at that time it will return some integer value. And each integer value has some significance. If our fork function or system call will return negative value, then it will represent the creation of child process. In that way, if our fork system call returns 0 value, it means that is newly created child process. And if it is return positive value, then it's called the return to the parent or the caller. Now, let's take one simple example, one simple program on the fork system call in a C language. Now here we need to include some header files, stdio.h, system/types.h, and unistd.h. Out of these, the sys/types.h header file actually used for the system calls. Now here, just look at the code. If we'll execute this program without fork, at that time this program will return hello world in a single time. If we'll place this fork function in this program and we'll execute this code, at that time this function creates one more child process and execute it. It means the same code is going to be executed twicely. That's why the output of this program is hello world, hello world. It means the child process has executed the same code, that is hello world, and parent process also executed the same code, that is hello world. Now just take one more example here. Like in this program, how we are actually going to identify which process is child process and which one is parent process. Now the same program here, but just we need to make some changes. Like in the main function we have called the fork function. Now when that control goes to the fork function, here we are going to execute the fork function, fork system call. If that fork is equals to 0, then here these statements create a child process because it returns the 0 value. That's why we have written the printf hello from child. Now here we'll come into the else part. If it returns the non-zero value, then it becomes the parent process. Now here we have written like printf hello from the parent. Now in this program, when we'll execute this program, we'll get the output like hello from child and hello from parent. That is totally depends on the value that is written by the fork. Now just one question here. What is the output of the following code? Now in this code I'll just explain what we have done here. Now here we have taken one function, same function like a fork fun. When the control goes to the fork fun, we have declared one integer age equals to 10. Now here we are trying to perform two different tasks with the help of this fork. Now when fork will return 0, at that time we are performing some operations, and when we are getting the non-zero values, that is again we are going to perform that task. So now please, what is the answer of this program? Okay, now we'll see the output of this program. Here the parent has age equals to 9 and child has age equals to 11. How it comes? We'll look into the code. Now when fork is equals to 0, at that time we are creating the child process, and here we are actually incrementing the value of a, that is plus plus. We are doing the plus plus, means the value of a becomes 11. Now that is going to be printed by the child process. And now when we'll come for the parent process, at that time we are decrementing the value of a. It means minus minus a. It means a, the parent process will print the value age equals to 9. Now some of the references. We have gone through some operating system concepts through some books, and we have referred some YouTube channels also. Now here operating system concepts by the Galvin, system program and operating system by the Dumdere, and youtube.com. Here we have used the TechTude channel. Thank you.